So this is the study guide for the polynomials test. So hopefully this gets you ready to take the actual polynomials test and you do well on it. Okay, so when evaluating p of x equals x cubed minus 1 is divided by x minus 3, a student can determine the remainder by evaluating p of 3. So what it's saying is, normally if we were doing the remainder theorem, we would set this equal to 0 and x would equal 3. So we would plug in a 3 for all the x's and we would get the remainder. So when we plug in a 3 for our x, we get 26. So p of 3 equals 26. So C is the correct answer. It's just seeing if you can pick out the correct notation. Okay, if a polynomial p of x is divided by x minus 2, the quotient is, oh, sorry, I'm missing the quotient. Hold on just a minute. Okay, sorry about that. That was the end of it. Which of the following must be true? So what it's saying is, if I divided it by x minus 2, x equals 2. So if I had plugged in a 2, I would have got the remainder is, but it's already right here. Remember, the remainder goes on top of what you're dividing by. So this is the correct answer. Alright, I got things beeping and stuff in my room. If you hear that, I'm sorry. Alright. And I have a typo right here. Sorry, that's supposed to be a -2. So this one looks really a little crazy, but it's pretty much exactly like the same one. So like, the equation of a volume of a rectangular prism in cubic units could represent the length of the prism, blah, blah, blah. It really doesn't matter. What they're saying is like, if I look at answer choice A, if I were to set that equal to 0, then I would have plugged a -2 in for volume. And if I wanted it to be the actual length, I would want it to equal 0. So that one makes sense. B doesn't make sense because when I set this equal to 0, I get -2. I would have wanted to plug a -2 in right there. Same thing for C. If I set this equal to 0, x minus 2 equals 0, I would have wanted to plug in a +2, and there's a -2. And then D doesn't even make sense because your remainder would be -2, which doesn't make sense. Okay. So once again, 1, 2, and 3 are all looking at notation and if you understand notation. So not even testing your math skills. Okay, so this one is testing your math skills. So notice you have a k right there. We want to know for what value k is x plus 2 a factor. Remember, in order to be a factor, we want it to have a remainder of 0. So we can use the remainder theorem really quickly. If I set this equal to 0, -2 is what I want to plug in for all my x's. So I'm going to replace my x's with -2. And remember, I want my remainder to equal 0 because I want it to be a factor. So what I'm going to do is I'm going to simplify all of this and work backwards to figure out what k equals. So 0 equals, this is -8. This becomes -8 plus, let me do this. K times a -2 is -2k plus 10. I'm going to get all my like terms together. So -8 minus 8 plus 10 is going to be a -6. I'm going to add the -6 to the other side. 0 plus 6 is 6. And in order to get k by itself, I need to divide both sides by -2. So k would have had to been a -3. Alright, so D is my correct answer. When the polynomial blah 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 is divided by x minus 1, what is the remainder? I'm going to do the remainder theorem really quickly. I'm going to set that equal to 0. X has to be 1, so I'm going to replace all the x's with the number 1. And whatever it gives me would be my actual remainder. Now, if you do not like the remainder theorem, you're more than welcome to work this out by actually doing division, but I don't have time. Okay, so 16 is the remainder when you divide that. And once again, I'm using the remainder theorem. Okay. Alright, so we're given this polynomial, which set includes all the zeros for the polynomial. So if I'm talking about zeros, I'm talking about where they hit the x-axis. So for A and B, I couldn't even do that in a calculator and find all of them because notice there's an imaginary solution. So the first thing here, no. So if you'll notice, it's already factored. I'm going to take all of those factors and I'm going to set them equal to 0. Alright, so the first one, to get rid of the plus 9, I'm going to subtract. So x squared equals negative 9. To get rid of a square, I'm going to take the square root. So x equals, anytime you do a square root, it's a plus and minus. The square root of 9 is 3, and because it's a negative, I have 3i. So I already know it's not C or D. Next one, I'm going to minus 5. I get 2x equals negative 5. Divide by 2, x equals negative 5 halves. Alright, so I already know the answer is A, but I could keep going, x equals 1, but the answer is still A. Okay. Which set of ordered pairs represents the x-intercepts of the function? So it's kind of like that last one. It's already in factored form. All I got to do is set the factors equal to 0. So x equals negative 3. Add 2 to both sides. 5x equals 2. Divide by 5. X equals 2/5. Remember, in order to be an x-intercept, the x-coordinate is a number and the y-coordinate is 0. So that's why I'm going to choose C. Alright, so notice f of x equals x plus 5, g of x equals that. I want to find the equation h of x where they're being multiplied. So I don't know if you can see that, but they're being multiplied to each other. So it's just a really complicated way of saying, hey, multiply both of them. So remember, you have to use the distributive property. So I'm going to distribute x to everything. So that's x cubed minus 2x squared minus 3x. And now I'm going to distribute the 5 to everything. So plus 5x squared minus 10x minus 15. I'm going to get my like terms together. Alright, so it looks like it's answer choice D. Which equation best represents this graph? All I gotta do is graph the answer choices and see which one actually matches. And answer choice A. Right. Alright, I need to write the answer choices out for this one. Actually, if you look at the attached study guide on haiku, you can see the answer choices, but I'm just going to do it really quickly. We're talking about end behavior, so the first thing I'm going to do is I'm going to graph this, and I'm going to look at the ends. So here's what it looks like. It's going, down, and then it's going up. So this is how we say it. If we're talking about the left side, we say as x approaches negative infinity, and if we want to say down, we say f of x goes to negative infinity. If we're talking about the right side, we say as x approaches positive infinity, f of x, and if we want to say up, we say goes to infinity. So whatever that answer choice would have been, that's the one. Alright, same thing with this one. Talking about end behavior, talking about this function, go ahead and graph it and look at the ends. Which way are they going, up or down? Alright, so these ends are definitely going up and up. So as x approaches negative infinity, that means left side, f of x is going to positive infinity, it's going up. If we want to say right side, we say as x approaches positive infinity, f of x is going up, is positive infinity. What does the solution to the inequality? So when is this greater than 0? I want you to graph this in your calculator, or you could actually just put all of this in Desmos. Either one you want to do. Graph it somewhere, Desmos or calculator, sketch a little graph, and then we'll talk about it. Okay, so it's literally saying, when is this curve above the x-axis? So it's above the x-axis from here to here, and then from here. So it happens to the right of negative 3, but to the left of 1, and then to the right of 2. So these inequality signs, if you're getting confused on them, it's just literally pointing what direction the graph exists. So right here at negative 3, to the right of it is our answer, so we did to the right. Right here at 1, to the left is our answer, so we did the left. And right here at 2, to the right of that 2 is the answer, so we did to the right. So that's what you're looking for. Okay, this is like the popcorn task we talked about. A piece of cardboard is 9 by 13. You're going to take away 4 square corners. So remember that's x by x. Alright, you were talking about volume. Volume equals length times width times height. So my length was 9, but then I took away 2 x's. My width was 13, but I took away 2 x's. And the height of the box is determined by x. So now I'm going to graph that and find a relative max. If you do not understand this, go back and look at those notes right now. Alright, so when you graph it and you find the relative max, make sure that you're looking at the y-coordinate. The y-coordinate is 91.438. I rounded a little bit, but that is the maximum volume. Okay, so it says what is the entire domain for the function? Sometimes I'm going to ask you for what's the maximum volume, and then sometimes I'll just ask you for an entire domain. So you just want to see, like, what's the number where it starts getting into the negatives? What's the first place it hits the x-axis? That's what you're looking for. So as long as as long as x is between 0 and 4.5, you'll have a positive volume. So you're kind of just figuring out, like, what makes sense for the domain in context of this problem. Alright. Notice that this one is talking about surface area, no longer talking about volume, so it's not going to work the way that we just did. So we had we had this 9 by 13 piece of cardboard. We cut away some corners. We're talking about area. Area is found by doing length times width. So we had an area of 9 times 13, which is 117, and then we took away these corners, which were x by x. So the area of those corners is x squared. X squared, x squared, x squared. So you had a surface area of 117. You took away 4x squareds. Your answer is A. Now I just want you to note that these problems are different because number 13 was talking about volume, 14 talking about surface area. That's why we use 2 different formulas. Okay, this one's nice, talking about which expression is equivalent. Remember, if x plus 3 is cubed, that means I write x plus 3 3 times, and then I'm going to distribute. I can only do 2 at a time. Alright, I'm going to distribute all of that to the second parenthesis. So here is what I get. I'm doing this fairly quickly because we've already done it in class. I'm going to get my like terms together. Okay, so that's what I get when I do those 3 parentheses cubed. Don't forget that you still had this stuff. So I also need to distribute negative 9x to x plus 3, which becomes negative 9x squared minus 27x. So now I'm going to put that down here at the bottom. Minus 9x squared minus 27x. So now when I look at this, these are going to cancel out, and these are going to cancel out. The only thing that's going to be left is x cubed and a 27. So my answer choice is A. Alright, suppose this polynomial, when it's divided by x minus 2, the remainder is 3. I'm going to stop right there. When I divide this polynomial by x minus 2, I get a remainder of 3. So here's what I'm going to do very quickly. If I was going to do the remainder theorem, I would set it equal to 0, so x is equal to 2. I'm going to replace all of those x's with the number 2. And I know that my remainder should be 3. So now I'm going to work backwards to figure out what k would have to be in order to get 3. This is 8, 12, negative 8, 26 plus k. So I get 3 equals 38 plus k. I'm going to subtract 38. 3 minus 38 is negative 35. So now I know that k is actually negative 35. Okay, so I'm going to clean this up. I don't need any of this anymore. I know that k is negative 35, so I'm going to go ahead and do that. So now what I'm saying is, what's the remainder when it's divided by x plus 1? So I need to plug a negative 1 in for all the x's now, knowing that k is negative 35, and I'm going to figure out what I get. So I don't know that 3 is the answer. I'm going to figure out what the answer is. And I got negative 48. And not sure, sorry, I was really close. Those are supposed to be 48s. So the answer is A. Okay, so x plus 3 is a factor of blah, blah, blah. What are the other two factors? So if I know x plus 3 is a factor, I can set that equal to 0. So x equals negative 3. So I can take negative 3 and I can do synthetic division. So 2, 6, 54, 162. Don't do anything to the first number, bring it down, multiply, add, let's see, multiply, add. If you have no idea what I just did, you need to stop this video and go back and look at synthetic division. So my answer is going to be 2x squared plus 54. So now I have a quadratic. I could use the quadratic formula, but I know that I could solve this really quickly just by getting x by itself. So I'm going to subtract 54 to both sides. So I got 2x squared equals negative 54. I'm going to divide by 2. So I got x squared equals negative 27. I'm going to take the square root of both sides. X equals, I know I have a plus and minus. I know that there's an I because it's a negative. And the biggest perfect square that I could pull out of 27 is 9 and 3. So the square root of 9 is 3. And then I'm left with the square root of 3. So my answer, plus or minus 3i squared of 3, B. It's not D because it doesn't have the plus and minus. Okay. The volume of a rectangular prism is represented by this. If the length is x minus 3, and the height and the width are equal, what is the width of the prism? So I can do the same thing I just did in the previous problem. Get x by itself, it's 3. Use that 3 to do synthetic division. 1, 5, negative 8, negative 48. Bring down the first number, multiply, add, and multiply and add. So I'm left with x squared plus 8x plus 16. This is a quadratic. It's a quadratic that can be factored, and it's actually a perfect square trinomial, but I'm going to factor really quick. So two numbers that multiply to give me 16, but had to give me 8, 4, and 4. So my two answers are x plus 4, and they're both the same, which is what the problem stated. So C is my answer choice. Alright, which expression is equivalent to? All I gotta do is get my like terms together. So I'm gonna kind of color code a little bit. So those two are like terms. If I add those together, I get x to the 5th. There's only one quartic. There's only one cubic. And then negative 1 and negative 5 become negative 6. So that one's easy, but it's also easy to, sometimes you just don't notice which ones are like terms and which ones aren't. So B is the correct answer. Alright, so this is supposed to look like a table. It does on the actual notes. Sorry about that. Okay, so which table values, the table below shows ordered pairs that belong to a polynomial function. Which conclusion is valid? Has a remainder of 3. Once again, I'm missing some stuff from the answer choices. I'm going to look back on the actual study guide and fix this really quick. Okay, A and B don't make a bit of sense. Alright, so notice, right here, I have 3, 0, meaning that x equals 3 would be an x-intercept. So if I worked backwards, that means that x minus 3 would have been a linear factor. Alright, if that confuses you, go back and watch the video on zeros, linear factors, and multiplicities. That's where that's coming from. Alright, same thing again. This is zeros, multiplicities, and linear factors. If you don't understand this, then go back and look at this. If we're talking about multiplicities, and it's x equals 1, that means it has a linear factor, an x minus 1. And it only occurs one time because it has a multiplicity of 1. The next one, if x equals 2, then it has a linear factor of x minus 2. The next one, if x equals 3, then it has a linear factor of x minus 3. Since it has a multiplicity of 1, these only occur one time. So all I have to do is distribute this back together. So I'm kind of doing the shortcut distributing. Alright, and then I'm going to distribute this to x minus 3. Remember that you can only distribute two things at once. Need a little bit more room, sorry about that. This is plus 9x squared. Oh, sorry, let me change that. This is a minus 3x squared plus 9x minus 6. I'm going to get my like terms together. Alright, so it looks like answer choice A is correct. Alright, so we're talking about what's the distance to the nearest hundredth between the two zeros that are closest to each other. Alright, so the first thing I'm going to do is I'm going to graph this in Desmos, and I'm going to find the two zeros that are closer to each other. Okay, so I put this in Desmo. I found the two zeros that were closer to each other. And then if I want to find the distance, I'm going to do the big one minus the little one. So that's how I'm getting 2.67. And it did say to round to the nearest hundredth, was why I rounded to two decimal places. Okay. The graph of the function, blah, 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 has zeros at... Sorry, I'm using my iPad to do this, and it does not like Word. So it has zeros right here. What is the other zero of the function? I would suggest just graphing this in Desmo. Oh, and here are the answer choices. My bad. Alright, so graph this in Desmos really quickly. Okay, so when I graph this in Desmos, it just, oh, sorry. You can see it just hits at 1, so the answer choice is A. Alright, so which expression is equivalent to blah, blah, blah. Okay, Apple computers are really starting to make me mad. There's a division sign between those. So what I'm doing is I'm dividing this by this. Okay, so what do I got to multiply x squared by to get x squared? 1. And then I'm going to multiply. 1 times x squared is x squared. 1 times negative 3x is negative 3x. 1 times negative 40 is negative 40. Then I'm going to change everything to its opposite side. Alright, and then I'm going to get the like terms together. So these cancel out. Negative 2x plus 3x is x. And then negative 37 plus 40 is plus 3. So my answer is going to be 1 plus remainder x plus 3 divided by what you're actually dividing by. So on the study guide, it's answer choice A. Alright, last one. Oh, just kidding. That was the end. Okay, so go back and watch videos. There's nothing wrong with re-watching videos. Ask me questions before you take this polynomials test. It is a hard test. I don't want you to bomb it. So reach out to me for help, or take some responsibility and watch a video again. Go back and look at notes. Ask somebody in your class for help. Figure it out. Alright, good luck. Bye.